everyone, again, welcome to another video. I hope everything is going on as you wish. And today we will talk about the concept of the duck curve. We will try to understand what the duck curve is, what is the sense behind the duck curve, what the duck curve tell us. And if you want, let's start without delay. And to understand the sense of duck curve, I think the sense of net metering should be understood. As you can remember in our last lecture, we talked about the concept of net metering. And as we already memorized, we said that if we are producing not enough energy for our system, we are importing some amount of energy from the grid. And if we are producing excessive amount of energy that is more than for our systems, we are exporting this excessive amount of energy to the grid so that to balance our system. And we can say that the energy fluctuations during that shopping, as we already said, we said that this is like a shopping. Net metering resembles a shopping. And energy fluctuations, the electric fluctuations during that shopping and the corresponding responses to stabilize the grid actually forms the basis of the duck curve. What I mean is, as you can understood, the left part of the screen is the main structure of the duck curve, and in the x-axis, we see the parts of the day, the hours of the day. And in y-axis, it represents the energy demand from the grid. The amount of energy that we are taking from the grid. When we are not producing enough energy, for example. And if we try to understand the graph, we can clearly see that there is a sharp decrease from morning to the noon, and the line reaches its lowest point at noon. And this point is called midday dip. But what this line constantly decreasing to the noon, and it reaches its lowest point, because as all we know, in morning and at morning and at evenings, all people are in their homes, they are doing their laundries, they are watching TV, they charge their telephones, their mobile phones, their computers, and all people are using electricity. But in contrast to that, at noons, people are in work, children are at school. There is not so much electricity usage compared to mornings and compared to evenings. And because of that, the amount of electricity that is needed, the amount of electricity that will be imported from the grid, will be reach its lowest at noon, because no one is using so much energy compared to morning and evening. But when we are going through the hours of 6 p.m. to 11 p.m., as you can see, the graph is rocketed. The line is rocketed. Why? Because as we said before, people are coming to their home. They started to use electricity. They do laundry, they do cooking, they are watching TV. All people start to use the electricity, and because of that, the amount of electricity that we have to import that we have to take from the grid is increasing suddenly. And this section is called evening ramp in the terminology of the duck curve. But I want to say that there is a confliction within that situation. What I mean is, all we know, at noons, the solar energy production is at its highest level. I mean, because we are taking the photovoltaic energy at its steepest angle, and the amount of energy that will be produced from the sun as at its highest level. But on the contrary to that, the amount of energy that is used by the people is its lowest at noon. And in the evenings, the people are using most of the energy at evenings or at mornings, but the amount of energy that will be produced by the sun is decreasing. And approximately it reaches like a zero at evenings. There's a confliction within that situation. Because of that situation occur, I mean, we are needing so much energy at evenings, but we are not producing so much energy, approximately zero energy, we can say, at evenings. We are needing not so much energy at noons, but we are producing at most energy at noons. Because of that confliction, the professionals make a comment that we should use battery systems. What I mean is, we should store the amount of the produced energy from the sun at noon, because we said that people are not using so much energy at noon, and the amount of the energy that we are not used at noon will be stored, and this stored amount of energy will be used at evenings, where the time we used energy at its most level. And with that sense, with that mentality, with that flow, we can say that the dependence to the non-renewable energy resources will be decreased. What I mean is, we said that during the evening ramp, I mean during the evenings when we are needing so much energy, since we want to import so much energy from the grid, we are taking energy from the gas or oil-fired generator. I mean, we are trying to taking the source of the electricity from the non-renewable energy sources, because we don't have enough renewable sun energy in order to compensate the amount of the level of electricity that will needed in evenings. We are compensate this amount of energy from the gas or oil fired, I mean non-renewable energies resources. We are producing our energy through that resources, and we are sending this electricity, this energy through the grid and to our systems, to our homes, I mean. But there is a problem that these resources are not renewable resources. I mean, they are non-renewable gas or oil-fired generators and resources like that. And also they have larger startup times and they are less flexible. What I mean is, these devices, these gas or oil-fired non-renewable generators are not able to boost up their electricity output when they are faced with the sudden demand change. I mean, when the electricity demand is increasing at evenings in a sudden, they are not able to respond to that sudden change in a flash. And unfortunately, since they are not able to respond to that demand in a sudden, the instability occurs within the grid. What I mean with the instability is that some voltage fluctuations or some frequency deviations occur within the grid. And at some point, it's turned into a situation that maybe we can face with the blockouts. And in blockouts, we can think that the amount that we want to take from the grid at the the times that we want to take the amount of electricity from the grid is so high that the grid cannot respond to that demand and it closes itself. And this is called blackout. Shortly, we can say. And let's continue with the heading of does the dark curve turn into a canyon curve? We will try to make a comment on that. As you see from the left graph, from 2018 to 2024, the belly of the duck, I mean the midday dip, the section which corresponds to midday dip, is becoming deeper and deeper and deeper from the 2018 to 2024. But what is the reason for that? Because from 2028 to 2018 to 2024, the amount of the renewable energy resources, the amount of the constructed solar power plants, the number of the solar power plants is increasing. And because of that, the electricity need that we will import from the grid will decrease, because now in 2024 we are more renewable energy resources, we have more constructed solar power plants, and we can make a comment that compared to 2018, in 2024 we have a deeper midday dip because we have more renewable energy resources. We are not, we don't need to take so much energy from the grid because we are already producing our own energy. So the amount of electricity that will be imported from the grid will decrease. We are enough for ourselves. And I want to point out another graph, the right graph. As you see, it make a comparison between the 2018 and 2023. As you see, it says in 2018, the curve resembles a duck. I mean, the amount of energy that is imported from the grid according to hours of the day, the graph of it resembles a duck. But since as we said before, since the amount of the number of the renewable energy resources, I mean the constructed solar power plants, the number of the solar power plants increased in 2023 compared to 2018, the amount of energy that is needed, that will be imported from the grid at the midday dip, is decreasing, and it resembles like a canyon. And they said that we can call it canyon curve instead of duck curve now, because the belly of the duck is now at its deepest point. And in today's video, we try to understand what the dark curve is, what the dark curve tell us, what are the precautions that we can take into consideration in response to the dark curve. We said that the battery systems, I mean the storage systems, can be used in order to reduce the dependence to the non-renewable resources when we non-renewable resources at the times when we are needing so much energy, such as evenings. And we try to understand the concept of does the dark curve turn into a canyon curve because of the increase in the renewable energy resources, the amount of the constructed, because of the amount of constructed solar power plants. We try to understand that points. Thank you very much for listening to me. See you in another video.